Hey everybody, in this next video lesson, we're going to talk about a couple of vocabulary words. The first two that we're going to talk about is called qualitative versus quantitative. The words qualitative and quantitative refer to specific sets of data. Qualitative data and quantitative data. Qualitative data is data that does not require numbers in order to describe what you're looking at. Now, I've got 4 different examples of pictures on the screen, and we're going to talk about the qualitative aspects of each one of these. So let's first start with this one on the left. We've got a tall scientist and a short scientist. Well, tall and short are qualitative observations about these two scientists. You can describe the color of their pants, the color of their coats. You can describe anything you want about this picture without actually using numbers. You will be using qualitative data or qualitative observations. What about this red square? Well, red right there. Red is a qualitative value or qualitative observation. You could talk about the fact that it is a square. Maybe it's got rounded corners. All of this is describing using qualitative data. This piece of rock, qualitatively speaking, we can talk about its color. We can talk about its shape. Looks like it's got sharp sides, ridges, anything without numbers. I think you get the idea. Finally, this last example, we've got an orange car. It looks like it goes fast. These are qualitative observations of these things. But now let's talk about quantitative. When you talk about quantitative, the prefix quant refers to quantity. So you're talking about numbers. So back to my scientists. Maybe we know exactly how tall they are. Maybe this first scientist is 1 meter tall. Well, that's kind of small. Well, maybe 1.5 meters tall. Where this one is 2 meters tall. He's so tall that you can't even see their head. So once we attach a number, a quantity to it, now it's a quantitative value or a quantitative observation. Maybe when you're looking at the mice, I see 2 mice, maybe 3 mice. Anytime you attach a number, quantitative. Over here, this square, you could discuss how far across it is. Maybe it's 2 centimeters long, 2 centimeters wide. You could talk about the area that it takes up on the screen. These are quantitative values. What about this piece of rock? Could you talk about the density? Could you measure the mass in grams? That's quantitative. Could you measure the volume? In other words, how much space it takes up? That's a volume. And that is quantitative data. And then you take the mass divided by the volume and find the density. That's also quantitative data. So anything that associates with numbers is quantitative. Finally, this car, we said it goes fast. What's its max speed? Maybe it's 200 kilometers an hour. Maybe it's 300 kilometers an hour. As long as you attach a number to it, you've got quantitative data. I think you get the idea of qualitative versus quantitative. Now let's talk about the concept of accuracy versus precision. Now, in normal everyday language, these two words are pretty much used interchangeably by the common public, but in science, they mean quite different things. Precision is a set of measurements that is close to each other. In other words, maybe you take a measurement of the same object in mass multiple times, and you write them down. And maybe you get like 5.2 and 5.3 and 5.9 and 5.8. You've got 4 measurements that are all relatively close to each other. But precision is based on kind of how wide the range of your values are. If it's closer together, then we would say that has high precision, whereas if the range is further apart, we say that has less precision. Each one of these numbers is precise to 1 past the decimal. But let's say another scientist comes along with a better instrument and they measure the same object. And instead of measuring to the 10th place, their instrument measures to the 100th place or 2 past the decimal. So their measurements are 5.24, 5.37, 5.85, and 5.79. Now my set of numbers have a range of values of 5.2 to 5.8, or a difference of 0.6 in range. But the other scientists, because they can go further past the decimal, have more exact numbers, and their range is about 0.61 difference between their smallest number and their largest number. And so as scientists, we want to get numbers that are precise or close to each other. And the best way to do that is to use an instrument that goes more decimal places, and those instruments would be better. We call those instruments more precise instruments. Now, the concept of accuracy, on the other hand, is when you take a set of values and you average them, and how close are they to the true value. Now, between my measurements and my other scientist's measurements, we all know that the other scientist was more precise because they use an instrument that went further past the decimal. But are we accurate? Well, do we really know what the true value is? If you don't really know what the true value is, then you can't make a judgment of how accurate you really are. But if we know the true value and we can average our numbers, then we could figure out who is closest to that true value, and as a result, judge who's more accurate. Now let's take a look at Bob and Frank down here, and take a look at their measurements. Bob measured an object. I don't know if it's mass or distance or whatever, but Bob measured it, and he got 5.4, 5.4, 5.3, 5.3, 5.2, with an average of 5.32. Now Frank had 5.4, 5.6, 5.5, 5.3, 5.8. So who is more precise? Well, I think it's pretty clear when you take a look at Bob and Frank that if you decide who has the narrowest range, even though they measured both one past the decimal, whoever has the narrowest range would be more precise, and that, of course, would go to Bob. Now, who is more accurate? Well, we've got the averages down here. What you'll notice is that those two averages aren't necessarily all that close to each other. Now, underneath this gray box right here, I have the accepted answer, the true value. The true value is 5.58, and based on whose average is closer to that, then Frank appears to be more accurate. Now in lab, which of them is better? Is precision better or accuracy? Well, actually, neither is better than the other. We strive for both. We want both precision and accuracy. We want precise measurements. In other words, we want measurements that are close to each other. So no matter who takes the measurement, if they're using the same instrument, they should come out to be about the same answer. Now, they won't always be exactly the same due to human error or maybe the way that you calibrated the instrument, but they should be within an acceptable range of each other, and that would make them precise. Now, who's more accurate? Obviously, we want to be accurate as well, because let's say we're measuring something that's 5.4, but the true value may be 10.0. Well, even if you're precise, if the correct value is 10.0, then you're not accurate, and that doesn't really give us much information. We just know that, I don't know, something obviously went very, very wrong. Now, can we adjust precision to be more accurate? I would say yes. Usually, if the answers are precise but not accurate, there must be something wrong with either your technique or the instrument that you're using. Take, for example, someone who's shooting free throws. Obviously, the goal is to get the ball inside the hoop. And so making the free throw would be considered accurate. And you take 10 free throws and you make 1 out of 10. Well, you are not very accurate. But you also notice that when you shoot your free throws continuously bounce off the left-hand side of the rim here. And so 9 out of 10 missed, but they missed to the left. Well, what someone might do is say, hey, why don't you scoot a few centimeters over to the right? That way you are lined up more in the middle of the hoop. And then you take 10 more and you notice that maybe you make 8 out of 10. And then, as a result, your average is more accurate because at first you were precise but not accurate, but now you're accurate and precise. And that's the ideal goal when it comes to measuring in lab. Well, that takes care of this video lesson. Thanks for watching.